All right, today we're going to take a look at problem solving. We're going to look at a variety of different problems. Obviously, if I solve every problem that you'd ever see, then that would mean that you'd never solve a problem. So this is not an all-encompassing kind of list. You'll have other examples in your homework that won't perfectly mirror what I'm doing. We're also going to solve more problems tomorrow. That is, we're going to have another day where I'm going to present you with some other different ideas about problem solving, okay? But everything we do in these two sections will have linear equations in them. Okay, everything will have no x squareds, no x's in denominators, no radicals with x underneath them, nothing like that is what's going to be present, okay? Linear equations. So we're actually going to just spend like all of the lesson today talking about problems themselves and how to think about and solve them. And then I have one slide that's actually got a little bit in terms of like some formulas, I suppose, if you will, on it, but you probably are familiar with them. So here's our first example. I'll read it while you write, and then we'll talk about it after we have had a chance for everybody to get it written down. A total of 387 tickets were sold for a school play. There were adult and student tickets sold. There were twice as many student tickets sold as adult tickets. How many adult tickets were sold? Does everybody have it written down? Got it? Okay, so one of the things that is valuable for me to say right now is that every problem we do will have one unknown variable. Now, there's sort of two things here we don't know. What are the two things we don't know in this problem? The number of student tickets and the number of adult tickets. But we have a relationship given between them, right? What does it say is the relationship between those two unknown values? Twice as many student tickets as adult tickets. Okay, so every problem we work is going to have that kind of a flavor to it, all right? So the first thing that you're going to do on any of these problems is if it's describing an unknown quantity, you need to tell me what that unknown quantity is and what variable you're going to use to describe it. So something like this. We have the number of adult tickets, and that's actually what we're looking for in our problem. And we need a variable to describe it, and there's no reason you can't use X, so if you just want to always use X, that's fine. However, if you want to use it sort of descriptive and use like A for adult, you could do that too. There are a few variables that are sort of not all that ideal to use. S is pretty bad because oftentimes S's look like 5s. T is not the best unless you're willing to put a curve on your T like that. So if you're willing to curve your T, it's okay. Otherwise, T's look a lot like plus signs. L, unless it's a capital, is a terrible idea because L's look like 1s, that kind of stuff, okay? So let's take a look at the relationship now again between the tickets that were adult tickets and student tickets. So it says the number of adult tickets is A, and you already told me before too that we don't know the number of student tickets, right? That's an unknown. But it's related to the number of adult tickets. How? It's 2 times that. So if A is the number of adult tickets, how could I represent the number of student tickets? 2A. Okay, is everybody good so far? All right, what other piece of information will we need to use that we were given? Yeah, 387 tickets were sold. So how can I use that piece of information plus the variables that I've constructed to create an equation? Right. The student tickets, you don't necessarily have to write this down, but if you're struggling to see how people are sort of thinking about this, the students plus the adults would be the total, right? So the number of student tickets was 2A, the number of adult tickets was A, and the total number of tickets was 387. At that point, that equation should be things that we've worked with before on all of our problems. So how can I simplify this equation? I can make it 3A. Yes, indeed. And then what? You bet. So grab your calculator or a pencil or whatever. Let's find out what is 387 divided by 3. 129. We did, except we need to actually make sure we're answering the question asked. So we could be asked a variety of things here. We could be asked for the number of student tickets. We could be asked for the number of adult tickets. We could be asked for both, right? What were we asked for here? Just the number of adult tickets, okay? So the answer is 129 what? Tickets. All right, so make sure when we're working with context that your answers include the context of what's going on. So it's 129 tickets sold. So tickets is good. Okay, does that make sense? Okay, fabulous. Let's try another one. So as I was using this example, I think this one's funny because I don't think you guys even know that this is how your landlines work at places. But for his long distance phone service, Keith pays $6 per month plus 8 cents per minute. Last month his bill was $17.84. For how many minutes was Keith charged? And the answer was not Keith should have gotten an unlimited data plan. Okay, that's not the answer. All right, there are quite a few things that charge like this. They charge you money like this. So, for example, there are some photographers that you would hire, and they would charge you a set amount for coming and doing your, wedding photographs or your graduation photographs because they went on site to do it, and then they would charge you an additional amount per picture ordered from them, stuff like that. So there's two kinds of costs that are associated when something's charged like this. There's a fixed cost, the amount you pay no matter what you do next. And then there's a variable cost, the amount that changes based on some amount you order, time that you spend, things like that. Okay, so this is a very common way of doing billing. It's also how things are billed oftentimes like when you get car repairs. So most of you have vehicles, or if you don't have one now, you kind of wish you did, right? And cars break down. And when they break down, there's a fixed cost. It's the cost that they actually have to pay for all of the supplies. And then there's a variable cost called labor. That's usually where they get you because it takes time to do the repairs, right? Okay, so we have a fixed cost here. What is the fixed cost? $6. So whether he makes any long distance charges or not, he's going to pay $6 just for having the ability to do so if he so chose, right? He also has a variable cost. What's the variable cost here? It's the 8 cents per minute. It's the minutes that he uses. And we're asked how many minutes is he being charged for. So we're going to start by defining our variable. So what is it that we don't know? What is the variable thing here? The number of minutes. So the number of minutes is our variable. And again, you can choose whatever letter you like. I'm going to tend to use some non-traditional variables today just for fun. So M. And we're going to use that letter M along with the other pieces of information to create an equation. So our fixed cost we said was 6. So we're going to have to pay $6 no matter what. And then he has a variable cost. The variable cost you told me was the 8 cents per minute. Okay, so first issue is this. 8 cents and $6 are not in the same units. Okay? I was at Homeland just yesterday, and somebody told me it was going to cost me this amount of money for a 2-pack of Reese's. Can somebody tell me what the problem is with that notation right there? There's a decimal and a cent sign. So work with me for just a second here, Megan. Do you know how much money this actually means? Like for real, the way it's written? Part of a penny. I should have been able to take a penny and give it to the clerk at the register and say, here's your penny. You can keep my 0.01 cents, right? Or we'll call that tax or something like that, right? People do this all the time, okay? So you have to make sure that your units match. Since my units are already in dollars, because I wrote the 6 down, I need to put the 8 cents in dollars. So what would 8 cents in dollar form be? Right. So 0.08 what? M. Because what we're going to do is we're going to take that 8 cents and multiply it by our number of minutes. That would be the amount we're being charged for the phone calls that we're making. Okay? And it says that at some given point, he had a bill, and the total of the bill was what? $17.84. Right. This is going to be the equation that allows us to find how many minutes he spent on the phone. So what would we do first? Subtract the 6, good. So I have 0.08 M equals what? 11.84. And then divide by 0.08. Hope you have your calculator. That's not one I'm going to do in my head. What would M be? Check it again. I have 148 as well. Just double check the calculator. Okay. All right, 100, but there, I mean, you could have gotten a partial minute. It would be okay, but this one's not. 148. Right, it's minutes. Right, we're going to make sure that we give context to our answers because the question itself had context. So in that given billing cycle, that month, he spent 148 minutes on the long distance phone calls. Okay, everybody good with that? Okay, this pattern of charging and billing is a very common one, so it's a good one to know. Dale is going to go for a walk. He takes 3 hours to walk 9.6 miles. What is Dale's speed? Okay, so this is a very straightforward question. You probably can answer the question without setting up an equation for me. But I wanted to show you how it would be set up, so when the problem's not so straightforward, you still know how to handle it. Does anybody know what the answer is before we start? Can You look at the information and just kind of figure out what it sort of has to be. 3.2 is right, Preston. Yeah, it's 3.2. Okay, so if you don't know how you did that, that's fine. But some of you are looking at that and going, why do I have to write anything down? I mean, I know what the answer is. But like I said, they're not always quite that straightforward. So I'd like to show you how you think about them. And this, I guess it's a formula, but this process is actually how you can do the next problem that we're going to do too, which is definitely more difficult than this one. Okay, so there is a relationship between distance, time, and speed. So distance equals rate or speed. That's the same thing. Times time. Right, so if you want to figure out how long or how fast you're going on average to drive somewhere, you can take the total distance you drove, and you can take the time it took you, and you can figure out what your speed was, your average speed, right? You can do that. And some of you do that a lot because you're athletes and you might do timed running or biking or things like that, and that's just a normal course of what you would do. So in this problem, you are told the distance. The distance that Dale walked was what? 9.6 miles. And for the purposes of what I'm doing in this problem, I'm going to go ahead and leave my units on just so you can see where the units still come into play in the end. The last two problems were sort of not so necessary to see that. It tells you the rate at which he's running or the time. It tells you the time. So we don't know his rate or his speed, so we need a variable to represent that quantity. So his speed, and I don't want to use S for speed, so somebody give me another letter. Q. Well, we're probably never going to get to use a Q, so that sounds like fun. Let's use Q. And then his time is 3 hours. Okay, so I'm wanting to solve for Q, the rate. How am I going to do that? Yeah, I'm going to divide by the 3 hours. So 3 hours, of course, cancel next to Q. And then 9.6 divided by 3, which is what Preston did just a moment ago for us, would have been that 3.2. So what I wanted you to see, and this is why I wrote out the units, is that we have here miles on top and hours on bottom. So what are my units? Miles per hour. When you see that division, we always use that word per. And with speed, we get that frequently. So you'll have miles per hour or minutes, miles per minute, or minutes per mile, depending on what you're doing. So you get a lot of that per notation when you're looking at problems that are related to distance and speed. So if you want to write it as MPH, that's fine. If you want to write it out as miles per hour, that's fine. If you want to write it as a fraction, miles over hours, that's fine. They all mean the same thing, just slightly different notations for it. So our answer is that Dale was moving at an average speed of 3.2 miles per hour. Okay, keep this in mind because the distance equals rate times time is valuable for our next problem as well. When I go to the next problem, I want you to understand that it's not as hard as it looks, so just jot it down. It's a little bit of a longer one to write down. This is the kind of problem people joke about when they talk about problem solving that sounds funny. 2 trains leave the station at the same time. One heads east and the other heads west. The eastbound train travels 80 miles per hour. The westbound train travels 70 miles per hour. After how long are the trains 330 miles apart? All right, so a picture might be helpful. I know for me, I'm a visual person, so I picture this in my mind, whether I draw it on the paper or not, a lot when I'm working with word problems. So I'm going to draw a picture. It says that we have a train going east and a train going west. So we can use left and right on my piece of paper. So here's west and here's east, right? So they're going, due west, if you will, which means straight left and straight right. And they're going at different speeds. So how fast is the westbound train going? 70? Okay, good. And how fast is the eastbound train going? 80 miles per hour. So there is a relationship. We don't know how long they're driving for or going for. We do know that in total at some point they're going to be 330 miles apart. They tell us that, right? And I told you just a moment ago too that this distance equals rate times time formula. It looks like dirt, just as a reminder. Dirt's a good way to remember it, is going to be useful here. Because what I really want is I really want this distance, whatever it is, plus this distance to equal what? 330, right? So let's actually figure out a relationship, or not a relationship, but a relationship, I guess, between those distances and the rates that we're given. So on the first one, what is the distance that the westbound train goes? Well, their rate is what? It's 3. No, that's not their rate. That's the miles we're going to get in the end. The rate's 70. And we don't know how much time they're going to travel for, right? That's actually what we're asked to find. So I told you just before that I don't like to use T unless I put curlies on the bottom, and I always put curlies on the bottom of my T's when I do math. So I'm good with T. If you don't like T right now, just switch it out for something else. Use an X or a Y or something, okay? So T here is going to be time for me. So we don't know what the time is, so it's going to be T. And we don't know what the distance is, but we do have a relationship between them. One of the distances is 70T. What would the other train's distance be? 80T. So these distances are not the same. This is distance 1 and distance 2. But we do know that distance 1 and distance 2 add up to what? 330, right? So if I take this distance, which is 70T, plus this distance, which is 80T, it will have to add up to 330. Because the distances are based upon the times that are being, I want to say driven, but it's not really ridden. I don't know. It's a train. What do we say? I guess they're driven. All right, what is 70T plus 80T? 150T equals 330. And then what? We will divide by 150. And Lauren, I heard you clicking over there. What did you get for the T? 2.2. Okay, did anybody else get a 2.2? Yep, fabulous. 2.2 what? What did we find? Hours. And I did a terrible job of modeling for you, so I'm going to go back up and fix it. This would be time in hours. Why is it in hours? You're right, but why? Yeah, because the speed's in miles per hour. So whatever the unit of time is, that's going to still be the unit of time. So it will take 2.2 hours for the trains to be 330 miles apart. Now notice, they're not equal distances from the train station, right? One of them's going faster than the other one. So they're different distances from the train station, but their total distance between them is 330. All right, good job. I think this is where I have one slide of notes. All right, good. I think perimeter and area are probably something that you've worked with very many times, I guess in very many classes, so to speak. Perimeter is actually the distance around an object. Specifically today we're going to work with squares and rectangles, so those are the only ones I'm sort of giving you formulas for. If the square has a side length of S, then its perimeter is 4S. And from a picture point of view, right, if you have a square, that's because all the sides of the square are the same. So we add s plus s plus s plus s, it's 4s. That is the perimeter or the distance around the object. When we're dealing with rectangles, rectangles have pairs of sides that are the same. Whoops, that's what I wanted. So typically speaking, when we write them down, we write W for the shorter side for width, and we write L for the longer side for length. Go ahead and make that a cursive L so that it doesn't look like a 1. And then again, for the perimeter, we would add up all 4 sides. Well, there's 2 W's plus 2 L's, and that would be my perimeter. Area finds the space inside of an object. So, like, you could talk about the square footage of this classroom, right? Square footage of a home, something like that. Space inside an object. Was working in my other class the other day, and they kept talking about the square footage of fun things like swimming pools. That's fun, more fun than, you know, the classroom. But when you're finding area, you're finding the space inside. And basically what you're doing is you're multiplying the dimensional lengths. So if there's 2 side lengths that are, or if there's a square that has all 4 sides the same, the 2 side lengths, s and s, are the same. So when you multiply s times s, you get s squared. But when you're working with a rectangle, of course, the length and the width are not necessarily the same. So when you multiply the 2 dimensions together, you get length times width. So shake your head if that's all review. I hope it is. You usually encounter some of this stuff like elementary school the very first time anyway. All right, so we're going to have a series of questions related to perimeter and area. Is everybody good with the screen? Can I switch the slide? We're all good? Okay. Here's our first pair of questions. They're paired up like this in your homework, so I paired them up like this when we were doing the notes. It says a square has a perimeter of 32 meters. What is the side length? So you can draw pictures if you'd like. Or you can use these formulas that you've written down if you'd like, whichever, you know, works for your understanding the best. I'm going to probably go with a standard formula perspective since I've given you the formulas. We have the perimeter of a square, and it has the formula for us. And the lovely thing about this particular formula is there's only 2 variables in it. And in the problem, you're told what one of the values is. Which one are you given, the P or the S? The P, and you're told that the P is 32 meters. So I'm going to leave my units off. The units will simply match at the end as they did at the beginning. What would I do to figure out what S is on this problem? We would divide by 4, you bet. And so S would equal what? 8, and what are the units on 8? Meters, because that was the original units given. 8 meters. Now think about, you know, from this perspective of the square, that's saying there's 8 on each side. Would that in fact give me a perimeter of 32? Yeah, it definitely would. So you should be able to visually, whether you write it down or whether you just think it through, check to make sure that what you did made sense. All right, the next one actually talks about the square and about area. So what is the area formula for a square? Generally, yes, but there's a more specific one for squares. S squares, right? Good. And on this one, it tells us it has an area of 9. So the area would be on the left-hand side of this equation. So this is going to be the one exception, area, that's not linear in our discussion for today. The one exception. How would I figure out what S is? We would take a square root, you bet. Now, normally when we take square roots, we've had this before. We talk about putting pluses or minus on things, right? Yeah? Do we have to do that here? No. Why not? Right. You can't have a negative distance. We are actually talking about a physical object. It doesn't make sense for the negative part here to happen. So we don't have to worry about that. So what would S equal in this problem? 3, and it would be Centimeters, good. So whatever the square unit is right here, we'll have the linear unit down here. So it'd be centimeters. Okay, all good? Fantastic. Okay, problem's going to have a little bit more context than the last one, and the third one we do here in a minute will have even more. This one tells us that we have a rectangular field, and it has an area of 7,098 meters squared. The width is 78. What is the length? Okay, so again, we can use the formula for the area of a rectangle. So the area of a rectangle was length times width, right? Okay, where am I going to put what numbers? Where will the 7098 go? For A. And where will the 78 go? For W. So length, if you write it carefully with the L, that's scripty, right? It was still is the unknown, and we have 78. And what would I do to find the length? Divide by 78, exactly. So what would be the length of this field? 91, very good. And 91 what? Meters. Okay, remember, this is a length, so it's singular meters, not meters squared. Squared would indicate area values. B is talking about the perimeter. It's the perimeter of a rectangle. So the perimeter of a rectangle formula was 2L plus 2W. That should say painting. Lift my T out. The perimeter of a rectangular painting is 372 centimeters. The length is 98 centimeters. What is the width? Where will the 372 go? P. Good, it's the perimeter. And where will the 98 go? It's L, it's the length. Now this one actually requires us to do a little bit more to solve it. First thing I need to do is what? Multiply the 2 times 98. So what is 2 times 98? 196 is right, good. And then what? Subtract the 196, very good. All right, so what is 372 minus 196? What is it? 176. Okay, good. 176 is going to equal the 2W. And then what? Yeah, we're going to divide by 2. So what will our W equal? 88. Ah, and somebody told me centimeters. I'm kind of out of space, so I'll put it here. 88 centimeters. Good? All right, let's try one more of this nature. This one's a little harder than the last ones because the answer and the information given is not quite as direct. The length of a rectangle is 4 meters longer than its width. The perimeter is 64 meters. What are the length and width? I'm going to draw a picture on this one because I haven't done that on the other ones, just to show you how that might look. I think this is a good one to draw a picture on as well. There are both things you don't know. I mean, you don't know the length or the width on this, actually. It's kind of like the first problem that we did with the tickets. We didn't know the student tickets and we didn't know the adult tickets. Okay? But we do know a relationship between them. So which is the information that we actually know nothing about? Like nothing. Okay, it's either length or width. Got a 50-50 shot. Somebody throw one out there. The width. You were right, Alyssa. It's the width. Because it actually tells me something about the length. It tells me that the length is 4 meters longer than the width. I still don't know what it is in terms of a number value, but I know something about it. So if the width is W, what would an expression for the length be? Close. 4 plus W, right. Okay, so more than is going to mean addition, right? If it said something like 4 times, or I think we had one at the beginning was the adult student tickets where it says twice as many. Okay, so that kind of language is going to indicate multiplication. All right, so what we have now is we have the length and we have the width, at least in terms of W, on our diagram. And we know the perimeter formula is 2 length plus 2 width. Okay, so where will our 64 go? P perimeter. And then from my diagram, I can use what the L and the W are. So L is actually what in my picture? Yeah, it's 4 plus W. And the width, W, is actually still W. So this is what we have as a setup for our problem. What would we do to solve first? Distribute, you bet. So 64 equals 8 plus 2W plus 2W. Now what? There's 2 different things we could do. We could combine the 2 W's, or we could subtract the 8. So I heard combine the 2 W's first, so we'll do that. So I have 64 equals 8 plus 4W. And then we will subtract the 8. So what is 64 minus 8? 56 is right. And then what? Divide by 4. So what do I get for the value of W? 14. And somebody said units. What was it? Meters? Meters. All right, so in my picture, we just found out that this piece is 14 meters. What is this piece? It's 18 meters because it's 4 more, right? That's what this formula or this expression said. Now, our question actually asked on this one for the length and width, right? So we have to report both on this one. That student parent, tickets thing didn't have that problem to it. It just asked for one item. So our width, our length, I don't care which one you call which one, but they are 14 meters and 18 meters. That would be our answer to this particular question.